Hello learners, welcome to this session. This is a session which is in series, session number is 15 and we are about to cover unit 6, the last topics, trends in data warehousing, and the title is data warehouse and Hadoop, and then we will cover data warehouse automation. So in the earlier sessions, we had seen at least 3 to 4 sessions which are concentrated completely on the trends in the data warehouses. So in the earlier session, we have seen the real-time data warehouses and what all the applications that we can consider under the real-time data warehouses. That was the topic that we have covered in the session number 15. And in this session, let us concentrate what exactly is the relation between the data warehouse, Hadoop, and how Hadoop, whenever we listen to the word or else the buzzword called as Hadoop, immediately another word comes into our mind, that is the big data. So there is very much good relation between the big data, its analytics, and then the Hadoop technologies that people are using. So in this, let us see what exactly and how this Hadoop helps to maintain the data warehouses as of now. So data warehousing with Hadoop is a strategy for data storage. So we have to remember two components here for the Hadoop. One is to manage or to store the data, and the other is the processing of the data. So both the components are being supported by the Hadoop technologies. So this particular Hadoop, it is a data storage, and then it allows businesses to effectively manage and analyze large amounts of structured and unstructured data. Mostly nowadays, if you consider the cloud databases or else the complete streaming of the data which is available in the form of big data, so in that particular context, mostly we are using the Hadoop kind of technology in order to support the data warehousing architecture there. So it is completely an open source Apache Hadoop software framework, one of the many data warehousing tools that provide an efficient way to process large data sets across multiple computers. So here in this particular session, let us focus on what is the Hadoop environment. Whenever we talk about this particular Apache Hadoop architecture or Apache Hadoop kind of systems, there are several software components attached with the Hadoop architectures. So let us keep on concentrating what all the technologies are used to support the data warehouse. So here in this particular Hadoop, it is actually becoming popular because of the scalability and the cost effectiveness. So nothing to worry about the hardware infrastructure. So whenever the data is been increasing, that to the streaming data and other kind of data, and if we wish to do the data warehousing and the analytics part, then the scalability is a big thing. So here there is nothing to worry about the scalability, and then it is more cost effective because the Hadoop is having the storage component as well as the computing component. The storage component will be taking care of the storage part or else the real-time data warehousing kind of part, and then the computing part will be taking care of the computing component. So although this particular data warehousing and Hadoop trend evolved some time back, however, these particular things are very much popular as of now. And this is completely an open source software. This is Java oriented open source software, and the three components you can say, or else the two components that we can say is, one is the storage component, the other is the processing component. Both the components are very much present in the Hadoop architecture. The storage component, we call it as the Hadoop distributed file system, or else in short we can call it as the HDFS of Hadoop. And then the processing component is termed as the MapReduce component. So this particular Hadoop ecosystem, in the Hadoop ecosystem, there are several softwares which will take part in the architecture or else in the data warehouse architecture. So not one particular software is completely taking care of the complete ecosystem of the Hadoop architecture. However, there are several participants in the form of several software forming a kind of ecosystem to develop various components of the overall architecture. So here the Hadoop data lake enables organization to store not only the structured data, it helps us in storing the unstructured data in its native format without any transformation or schema enforcement. This particular thing already we had focused on real-time data warehouses, wherein which there won't be much time in order to transform the data into a particular format. However, the complete thing can be taken care in the form of a data lake, and the analytics can be done against the data. So here mostly the Hadoop uses the NoSQL databases. However, most of the people, whenever we talk about the RDBMS, we talk about the SQL kind of databases. But here NoSQL databases are the prime component of the Hadoop to provide more flexibility when it comes to storing different types of information. Not only one particular information is being stored on the systems like HDFS, when it comes to the big data. So most of the data will be coming from either it may be a log data, whether it may be a streaming data, whether it may be a multimedia data, whatever the case may be. All these formats will be supported whenever there is a particular format and there is a particular format to support, and it will be there in the form of a Hadoop data lake, which enables the organizations to work with using the NoSQL databases. Furthermore, this Hadoop distributing model enables far greater speeds. That is the main advantage that we are getting. One is the scalability, one is the second one is the cost effectiveness, and the third one is coming in the form of a greater speed kind of thing, wherein which when we compare it with the traditional databases. Here you can see on the screen, on your screen, a kind of typical Hadoop data warehouse architecture, and this is just a typical abstract kind of thing, wherein which it is there in the form of blocks. However, when you come to the middle part, that is the middle tier, that is the hardware platform, Hadoop platform, there you can see there are several software ecosystem or else Apache software things. Those are comprised, and then they are supporting the data warehouse kind of architecture over here. When you see this particular conceptual Hadoop data warehouse architecture, it is a clear-cut picture wherein which what are the various sources. You can see on the left side there are various operational systems or else logs kind of thing, and it is supporting, this particular architecture is supporting as the semi-structured, and else non-structured data. So here you can gather the data from any of the sources over here, which are called as operational source systems, and then there are certain technologies supporting over here. You can see Scoop is one particular component. You can see here we have written the Scoop, and then there is Flume and Kafka. So all these things are forming a kind of ecosystem over here, and these are supporting a kind of extraction kind of thing, wherein which the data, whatever the OLAP data that is available in the form of source systems, that is being totally extracted by using Scoop software, or else Apache Scoop, or else Apache Flume and Kafka. So here, when it comes to the storage part, you can see here HDFS is the storage part that can be considered, and then in the core database system also there is a primary component called as the ETL component, extract, transform, and then the loading component. Here the transformation is done using, once again, there are several technologies available in Apache. One by one we will see it in the later slides. So these particular technologies will be there acting very prominently here, playing the main role, and then they'll be transforming the data, and then there are certain analysis tools available over there. Suppose if this particular thing comes from the Hadoop system, the source systems are from the HDFS itself, then there won't be any problem, and the processing will be done very much faster, and then the outputs, the analytics part will be taken care very immediately. However, these can also be fed into enterprise data warehouses also. So suppose if the component, the data warehouse component is not to be functioned over here, it can be transformed, or else we can call the technical word called as the exported. So the whole data can be transformed, and then it can be exported to the enterprise data warehouse. You can see here, enterprise data warehouse, and then later on using the visualization tools or the analytic tools, you can analyze and you can get the results in the form of reports and other kinds of things. So one by one we will see data extraction. So in order to get the data to be extracted, tools like Apache Scoop can be utilized for data extraction from the OLTP databases, online transaction processing systems. So Scoop can also be used to export data to OLTP databases after data processing is completed within the system. So here on the slide you can see there are two things we are highlighting. One thing is it is extracting the data using the Apache scoop, and then it can be fed and the results can be immediately known. However, if it is not the case and it should be exported to the enterprise data warehouse, then the second point, the scoop can be used to export the data to OLTP databases after the data processing is completed, and then the EDW will be taking care of the rest of the part. So coming to the data transformation, which is very much prominent component here in the data warehouse architecture, this data is ingested into the Hadoop system precluding data staging, and then this ingested data is transformed and loaded into target data repositories within signed directories. Like here there are certain tools which can be useful, like one is the Spark, and the second one is the Cloud Era Impala, and then Apache Hive. Here Apache Hive will be acting as a structured query language component, wherein which we can write the queries using the Hive SQL language, and then we can get the like reports, or else you can get the outcomes of that particular queries. So Apache Pick or else MapReduce, the integral processing component of Hadoop, can be used for data transformations. So here in this particular ecosystem, you can see there are several participants over here. One is we are talking about the Apache Spark. The second one is we are talking about the Cloud Era Impala. Third is Hive, Apache Pig, or MapReduce. So all these components are helping in the ecosystem, wherein which when it comes to the component of the data transformation. So the third thing is the data loading. So in this context of Hadoop, data loading implies data hosting with Hadoop through Apache Hive or Cloudera Impala. Otherwise, if at all it is to be exported, so data can be exported to external data warehouses also for ancillary analysis. So both the things, as we have seen it in the block diagram, conceptual Hadoop data warehouse architecture, the right side part, whatever we were focusing upon is the EDW part. That also will be taken care by the Hadoop platform. So coming to the data analysis or the visualization part, which is on the extreme right hand side of the data warehouse architecture, this is nothing but the exported data, whatever that is there through the external DWs or the data sources which are already been there in the DWs in both the types. From the system of BI, that is business intelligence, the data analytics and visualization tools, we can using these particular tools we can see the reports or else the visualizations like the bar graphs, pie charts, or whatever the case that we wish to look into. So Apache Scoop can be used for exporting data assisted through Python or shell scripts. So the data is ready and it is being transformed and it is available in the repositories. So suppose if it is to be pushed to the external EDW, then there you have to write certain scripts using Python or else some sort of shell scripts using Linux or something like that, wherein which directly the data, whatever that is available in the repository there, that can be exported to the EDW. So once again, you just see have the thing. One on the left hand side, we have seen the source systems and using Scoop and Flume Kafka, depending upon the type of data. Here we are using the tool. So these particular tools will be helpful in extracting the data, and the HDFS is the storage part in the Hadoop ecosystem. Then transformation it is done. And then these particular things are helping us in the loading part and other kinds of things. Suppose if there are straight away the analysis tools are connected over here, directly we're using some sort of language like Spark and other kinds, like Hive and other kinds of language, structured query languages. You can directly extract, do the business analysis kind of part. Otherwise, it needs to be some sort of scripts needs to be written over here, and then using the Scoop, once again you can push that particular export that particular data to the EDW. So let us see how these particular technologies, whatever that we are talking about, the Apache technologies, what are those and how they are useful in overall ecosystem. One particular thing is very much famous, called as the Hive, Apache Hive, and this particular Apache Hive is an open source SQL like query language, use it for querying language data sets. So when it comes to the big data, so there will be large sets of data or large data is available, and in the HDFS the whole data is being stored into, but using this particular Hive, a kind of structured query language, the whole retrieval can be done by the done from using this Hive. Some organizations prefer to use Hive for its ease of use and speed. For the next thing, the next technology that we can talk about is the Apache Spark, and this is an open source distributed computing platform. This is not a storage kind of thing. However, the Spark comes under the computing platform that can be used for data processing, analytics and machine learning. So here Spark is the language which is used in order to write the kind of modeling that needs to be done using the machine learning, or else the kind of analytics that needs to be done from the data that is already stored in the HDFX. The third platform is the Apache DW platform, and this is an open source DW platform that enables organizations to store and manage large amounts of structured and the unstructured data. So there are certain tools used over here for this under this particular suite. This is completely a suite kind of thing. It comes with several technologies called as Hive, Pig, Scoop, Flume, Uzi, HBase, and there are several things. And this particular DW platform is a kind of package, a kind of automation package, which is available in the form of suite. And for managing, analyzing, and transforming the data, this particular Apache DW complete suite platform is being used. And then there is another software called as a Druid. So this Apache Druid is an open source distributed real-time analytics system which is designed for fast analysis of streaming data. So as it pertains to kind of big data architecture, so streaming data is being taken care, and that is available in the non-structured format. So in order to support this particular real-time analytics in the Apache ecosystem, this particular Druid is used to analyze the streaming data from sources such as say weblogs or else sensor networks and other kinds of things. It provides a low latency query processing capabilities with high scalability and commodity hardware clusters. So there is another software called as Apache Kylin, and it is a kind of distributed OLAP, distributed online analytical processing system, wherein which it is designed to provide interactive analysis over massive data set, and this is helpful in the real-time analytics part also. For the business intelligence applications such as reporting dashboards or ad hoc exploration talks. So for such kind of things, this particular Kylin is used. And then there is another technology called as Spark. This we had already seen in the earlier slides. And this is an open source cluster computing framework designed for fast computation across a wide range of workloads, including batch processing, machine learning algorithms, streaming applications, and much more. So this particular Spark is nothing but it is, you can write some sort of programs, the computing programs, and this is among the ecosystem, whatever the software that is available in the Apache, this particular Spark comes under the computing framework. So most of the computing frameworks is been taken care by Apache Spark software. So what are the advantages that we are getting it from the Hadoop DW architecture? One is that the heterogeneous data processing at very high scales is possible. So that is one of the advantages that we are getting. Second one is there is a kind of improvement in the ETL technologies. Here we are not only we are doing with the structured data that is available, however, whenever it comes to the big data and other kinds of large volumes of data, here the ETL would be a big problem. So using this particular Hadoop, the throughput, processing throughput will be very much high in the Hadoop DW. So it is helping in real-time data warehousing. That is the third advantage that we are getting. Efficient workload management, because we have each and every software that constitutes its own functionalities. So, and the whole thing is been developed by one particular company called as Apache. There is a very good sync and synchronization, orchestration between the softwares that we had already discussed. So this particular suites will be working very much fine in order to share the workload management. Hadoop offers architectural and data level flexibility through scalable and configurable components. Then the total cost of ownership of the data warehouse system can be reduced through elastic utilization and customization, thereby increasing the return on the investment. So these are some of the advantages which are like highlighted for the Hadoop and Hadoop DW. And then whenever we talk about the high scale architectures, almost the challenges are also are there. Some of the challenges are there, and most of the researchers, they are working on these particular challenges when it comes to the DW suites available from the Apache. So permeating the benefits of patterns in raw data to the structured component of data warehousing, that is one of the challenge that that the Hadoop DW is encountering. The second one is data propagation latencies may arise in certain cases where large amounts of data are made available. As this particular architecture constitutes in order to cater to the big data or high volume data, so there will be some sort of latencies occurring. So that particular latencies, whatever the propagation of the latency, that needs to be addressed in some using some sort of technologies. The third one is use of Hadoop as an archival repository. When we talk about the HDFS, which is the storage part of the whole Hadoop architecture, however, use of this particular thing will be catering to the nearest real-time analytics. It will be supporting real-time analytics. However, when it comes to the part of storing the whole archival of some 6 months data or else 1 year data, it would be a tough task. So it may be whenever you do such kind of things, obviously the cost also will be escalating for import, export and other kinds of things. So this is the third challenge that we can talk about whenever the Hadoop and DW architecture comes into picture. Then the last topic which we had seen in Unit 6 is the data warehousing automation. So in this particular data warehousing, right from Unit 1 to Unit 6, we are talking about several types of tiers. So one is the data collection from some sort of operational resources, and then there will be a tier constituting of ETL, and then there will be a tier wherein which the tools are available in order to query against the data warehouse repository that is available. Here, they are trying, in most of the organizations or software companies, they are trying to get some sort of suites wherein which helps us in the complete threading of the automation. So that is how the trend is moving, and the latest trend is towards the data warehouse automation, which we call it as the DWA, which deals with accelerating and automating the data warehouse whole life cycle, right from the conceptualization till the implementation and usage of the BI tools upon the data repositories, till that they wish to form a kind of pipeline right from the sources of data that is available till the data analytics part. So those particular things they wish to do a kind of automation. So most of the companies are focusing on the DW automation, and some enterprises may technically perceive it as automation, beginning from analysis of source systems right up to the testing and documentation process. So some are working on systems like testing and documentation process in order to automate certain kinds of things, but some are some companies are working on right from the conceptualization till the implementation part. So this particular data warehousing automation involves several tools. As we had talked about the Apache, it is having a wonderful suite to support each and every component. And we call it as the Apache ecosystem. Here also, most of the companies, they are also in the invention of certain suites which have sophisticated tools in order to automate the planning processes of data warehouse, in order to design the data warehouses, in order to integrate and implement the data warehouses through their life cycle, reducing the repetitive and time consuming tasks. So they wish to lay down a kind of pipeline kind of architecture, and there will be several sorts of software which will be constituting in between, so that the whole life cycle has been completed right from the start till end. The automation process requires careful thought for evaluating and selecting the right tools. So when you talk about the automation part, essentially all these things, all these four components will be there in the automation part. One is a source data modeler, So in order to model the source data, there should be a kind of module available. Then the dimensional modeler, wherein which the whole data needs to be converted into a kind of dimensional modeling. And then third one is the robust ELT engine or else ETL engine. Extract, load and transform, or else the extract, transform and load kind of things, that too with high performance characteristics, that needs to be there as the module available in the DWR automation. And the third one is in order to connect, in order to lay down the complete pipeline right from the source till the end, there should be a kind of connectivity for seamless integration with various data sources. So these are the four essential components. If you can integrate certain softwares along with these particular four components that we are discussing here, so automatically a kind of database automation will be coming into picture. So coming to the advantages, end-to-end solution is one particular advantage. No need of thinking of what kind of thing goes into the extraction, what kind of software needs to be used in order to transform the data, what kind of software needs to be taken care when it comes to the loading kind of thing. So no need of like focusing on that particular individual kind of softwares. However, end-to-end data pipeline acceleration will be there when we talk about the data warehouse automation. So automation of data capture and streaming, automation of data management and integration, optimization of data propagation paths, ensuring the automatic data flows in the entirety. So all these things are constitutes the advantages of the data warehouse automation. So in this particular session, what we had focused is we had focused on the Hadoop architecture and the data warehouse, how it is related, and how we can do the data warehousing part using the Hadoop and its Apache ecosystem software. And then we had seen certain advantages and then we had seen the challenges also. And later on we had concentrated upon the data warehouse automation. What are the four modules that constitutes to the data warehouse automation that we had seen. And then what are the advantages that we are getting whenever we try to automate the whole data warehouse architecture. Hope you got to know both the components in the today's session. However, if you want to read more, you go to MCS 227. That is the course on data warehousing and data mining. In Unit 6, both the topics are being covered. Thank you. Thanks for patient listening.